Hello! Welcome to today's lesson on radioactive damage. Today we will cover the distinction between direct and indirect radiation damage. Then we will explore how the hazard level of a radioactive source depends on the type of radiation emitted and its dose. So far we have learned about alpha, beta, and gamma radiation, including their associated penetrating powers. You are familiar with how these different types of radiation interact with materials and their respective abilities to penetrate through various substances. Building on this foundation, we can now introduce the concept of radiation damage. Understanding how radiation affects our cells and tissues allows us to better assess the potential risks associated with radioactive materials. As we'll see over the course of this unit, radiation can pose significant harm to living things. Let's begin by understanding the direct damage radiation can cause. When radiation enters our body, it can cause damage by directly colliding with structures within our cells. This type of damage works like a tiny bullet shooting through the cell components, potentially destroying them. For example, alpha or beta particles can strike the DNA or other critical parts of the cell, causing significant harm. Direct collisions can lead to cell death or malfunction, making it an immediate and serious threat to the body's tissues and organs. The other type of radiation damage that we are going to explore is indirect damage via ionization. Indirect damage occurs differently and is also quite hazardous. This type involves ionization, where radiation interacts with molecules in the cell to produce ions. These ions can subsequently react to form harmful substances, such as acids, which can damage cellular components. One of the significant risks of ionization is its potential to significantly increase the likelihood of cancer. The free radicals and reactive molecules formed during ionization can alter the DNA, leading to mutations that may trigger the uncontrolled cell division associated with cancer. Not all radiation is equally dangerous. The hazard posed by a radioactive source depends on the type of radiation it emits. We will explore the associated risks of each radiation type in the next lesson. Moreover, the dosage of the radiation, how much exposure a person or organism has received, plays a crucial role in the severity of damage. The concept of dose considers both the intensity of the radiation and the duration of exposure. Think of it like spending time in the sun. A few minutes of sunshine might give you a healthy glow, but hours of exposure without protection can lead to sunburn or even more severe consequences like skin damage over time. Similarly, even relatively safe types of radiation can become hazardous if exposure levels are high or prolonged. We will delve deeper into the concept of dosage in an upcoming lesson. In today's lesson, we delved into the concept of radiation damage and its impact on living cells. We discussed two main types of radiation damage, direct and indirect. We learned that direct damage happens when radiation particles collide with cell structures, leading to immediate harm, while indirect damage involves ionization, creating harmful substances that can lead to conditions like cancer. We then explored how the hazard level of a radioactive source depends on the type of radiation emitted and its dose. Understanding these concepts enhances our knowledge of the risks associated with radioactive materials and the importance of managing radiation exposure.